Okay, so yesterday we did what I would refer to really as just level 1 type problems. When I say level 1, I mean they all follow really kind of same suit, okay? And so we're going to flip to example 3, which is a right triangle problem. You guys all good with that? Okay, and we're going to teach you an important lesson here. And we're also going to look at different ways of diagramming these type of problems. Again, I always divide it up like that. It helps me organize my work, and honestly, it probably helps you follow it better if I divide it up in that way. So, and it says a right triangle has a base of 12, and the base remains constant while the height and area increase. The area is increasing at a rate of 8 centimeters squared. At what rate is the height increasing when the area is 64? So does it look familiar? We did a problem similar to it, right? Except in the last problem, both the base and the height were changing. Everybody see that? I want you to consider this situation. Try to ignore it. It's hard to ignore though, isn't it? It's hard to just block out of our brain. Okay, this triangle, what is changing? The height. The hypotenuse changes too, right? The area. What does not change? The base. And this is something that's extremely important when we understand related rates problems. Area is equal to 1/2 times the base times the height. Are we all okay with that? Here's the deal. Is the base changing? No. Is the height? Yes. So you can't, if you knew the height at this time, you couldn't plug it in because it's changing. But you told me the base is not changing, correct? So you can plug in this 12 right now because the base does not change. Do you see my point? Okay. So area is then equal to 1/2 of 12, which is 6. We good? What are we looking for in the problem? H prime. If I take this derivative, will I come up with H prime? Yeah, so let's take the derivative with respect to time of area equals 6H. Anybody? So A prime is equal to 6H prime. We all good with that? So I have A prime is 8. So 8 is equal to 6H prime. So H prime is equal to 4/3, and our label is going to be centimeters per second. See how by understanding what's changing, what's not, we're able to make the problem pretty easy, right? Now again, if the base and the height were both changing, you would have to use the product rule. That'll be a little bit more complicated. Let's check out problem number 4. It says an airplane is traveling east at 600 miles an hour. What? Okay, sorry about that. I'm not sure exactly where the notes were pulled from. This has been a very discombobulated section over the years. Can you try this one wherever you are? Yeah. So for people on YouTube that may not be here today, which I don't think is anybody, but you could turn to example 5. So, oh, and that's that part as you look through this. Okay, it says an airplane is traveling east at 600 miles an hour. Another is traveling north at 750 miles an hour. If they left the airport at the same time, how fast is the rate of their distance apart increasing after 2 hours? Yeah, great, awesome, good. Way to see it. So we got airplane going north. We got airplane going east. Okay. Airplane going north, airplane going east. How far apart are they? We'll call that distance D. Everybody good with that? Let's try to write down some knowns and unknowns. First of all, I just heard somebody say that they see right now that the relationship is the Pythagorean Theorem. We all okay with that? So we've got n squared plus e squared is equal to d squared. So we have a lot of things that are changing here, though. Is n changing? Yeah. We know n prime. What is n prime? Yeah, 750. Is e changing? Yeah. What's e prime? 600. Is d changing? Yeah, and we're actually looking for d prime, aren't we? So lots of different things here, okay? So, yeah, that's the relationship, all right? Let's take the derivative and just kind of see what happens. And I really do like this example. Part of the reason why I really like it is just because sometimes you just take the derivative, you don't really know what you're going to get. And you just have to say, well, we'll take it, we'll figure out the rest as it comes. Anyway, derivative of n squared. Good. Derivative of e squared. Equals. Okay, so the first thing I'm concerned about is I'm looking for a d prime. Did our derivative come up with a d prime? It did. However, we came up with some other pieces. For example, we don't currently know n, do we? Can somebody tell me if n prime is 750, what does just n represent? So n prime is the rate at which we are flying north, which is 750. What would just n represent? The current distance. Yeah, we don't know that current distance, do we? But we have some interesting information. The plane travels at 750 miles an hour over the course of 2 hours. So if it's 750 each hour in 2 hours, then how far has it traveled to the north? 1,500. So again, so the one going to the east, 600 miles each hour. Yeah. And if it's been 2 hours, 1,200. So I've got 2 times n, so 2 times, oh boy, 1,500 times what? 750 plus 2 times 1,200 times 600. Whoop, Mr. Gens. Equals 2 times, shoot, if n is 1,500 and if e is 1,200, could you figure out d? How would you do that? Yeah, you just use the Pythagorean Theorem, right? So I'll take out my calculator, we'll figure that guy out. And we'll quit that. We have 1,500 squared plus 1,200 squared. Square root of that guy. Whoop. Mr. Gens. Square root. Answer. 19, 20, 93. Thank you. Does that allow us to solve for d prime? Can I make our job just a little bit easier? You notice how everything's being multiplied through by 2, right? I could just divide both sides by 2 and get rid of those 2's, right? Yeah, I'll just divide through by 2, and that way this guy's gone, this guy's gone, this guy's gone. So now I could take 1,500 times 750 plus 1,200 times 600. So on the left-hand side, I get 1,845,000. It's like my bank account. And then what do we do with that? So YouTube, when I said that, they laughed at me. I don't know why they don't think that that represents my bank account. I'm a very good saver. I follow the, who's the financial guy? I follow the Dave Ramsey plan. Oh, yes, thank you. Very astute, Mr. Carter. Not too bad, huh? Okay, I would like to move to this type of problem. Do you have the ladder that's 12 feet long? Okay, so so we have this one, then we have one more, and you'll be done. So a ladder's 12 feet long. This is a great problem that kind of builds off of what we just did. Ladder's 12 feet long. It's sliding down the side of a building. So I'm going to put a building here. We got a door. I'm going to put a couple windows in there. What else would you like on your building?
Flowers.
You want, oh my gosh. We got flowers. They're ferns. We got ferns. We got grass. We'll have, I don't know, we'll have a rose there. Yeah, whatever. We got some roses. All right, whatever. Okay, that's my building. Whatever. And we've got a ladder. How long is the ladder? 12 feet. And it says that the ladder is sliding down the building. Okay? The base of the ladder is moving that way at 1 foot per second. The question is like, how fast is the top of the ladder falling when the base is 10 feet away? Oh, wow. Huh. Let's give some variables. What do you want to call this variable here? B. Should we call it B for base? Okay. And then what do you want to call this variable here? H. So here's what we have to decide that I want people to think about. Is the length of the ladder changing? No. Is the height of the ladder changing? Yes. Is the distance of the ladder from the base changing? Yeah, so see why those are variables, but this will not be? Somebody give me an equation that then relates that together. Yep, so b squared plus h squared is equal to 12, or 144, yep. So let's think about some of the things we know and some things we're trying to find out. It says the base of the ladder is moving at a rate of 1 foot per second. So what does that mean? What do I write on the board? B prime equals, all right, we got that. It says, how fast is the top of the ladder falling? So how fast is the top of the ladder falling? So what are we looking for? H prime. When the base of the ladder is 10 feet from the base, so what does that mean? B is 10. Everybody got the pieces? I just want to check. I'm looking for H prime. Will I come up with an H prime when I take this derivative? Yeah, so that's good news for me. You guys are smart. Derivative with respect to time of b squared plus h squared is equal to 144. So, what is the derivative of b squared? 2b prime, good, plus 2h prime is equal to 0. You can see where some people maybe would still put 144. Yeah, we forget that the derivative of a constant is 0 in that situation. So let's put in some of our knowns and unknowns. We have 2b, so 2 times 10 times, 1. Look at that. Plus 2 times, do we know the current height? No. Yeah, I've got to figure out the current height if I'm looking for h prime. So, Colin, how did you say we're going to come up with this h value here? Yeah, Colin says if I take this guy right there and just plug it in right here, I can figure out h pretty quickly, can't I? Because if you plug in 10, what's 10 squared? So I get 100 plus h squared is equal to 144. Or rather, h squared is equal to 44. Unfortunately, it's not. So we're going to take the square root of, a good thought, the square root of 44. It's like what, 6.7? What do we got? 6.63. Okay? So this is 20 plus 2 times 6.63 times h prime is equal to 0. Or 2, well, what is 2 times 6.63? Thank you, 13.27. 0.27 h prime is equal to negative 20. Let's take negative 20 divided by 13.27, and I get negative 1.51. What's my label? Yeah, we've got that feet per second. Can somebody tell me why is it negative? It's falling, it's going down. Yeah. Like your answer.
I didn't catch that part.
Street light. Last one. Nope. Street light minus street light. This is the last one.
It's the very last one. It is the old.
Street light is mounted on top of a 20-foot pole. Is this height changing? Is the street light growing? No. Okay. A man is 5 feet tall. He's got a really long neck. He's walking away from the pole at a speed of 4 feet per second. He's got a shadow. Okay? I'm going to call that S for shadow. He's walking away from the street lamp. Do you think the shadow is changing? Do you think the shadow is getting bigger or shorter? Right, so the shadow is getting bigger. I'll try to illustrate it really quick. But so if I draw a triangle here, notice the length of the shadow there, and then if I put the man out here and I draw it like that, notice how the shadow increased? You see that? So the shadow's getting bigger. All right, so we've all agreed on that. Is his distance from the lamp pole changing? Yeah, so the distance from the lamp pole is changing, and S is changing as well. Right? Oh my gosh. All right. Thank you, Lindsay. I love the sound effects. So here we go. The distance from the lamppost is changing. The length of the shadow is changing. The heights are not. Can you think of a relationship here? And it's not the Pythagorean Theorem.
E plus S from the shadow from the pole.
Yep.
That's all I got.
Focus on the triangle. Focus on the triangles.
Times 4.
Proportions. Okay, so King Leon sees two triangles that are similar. So if they're similar, then therefore their sides are proportional. Okay, so what I'm going to do is I'm going to write an expression, and the expression is going to be this. It's going to be the height over the length. Okay, so let's start with the easy one. And this is how I love to set up proportions. Okay, I write down a label so I don't mix it up. Height of the man, 5. And then the length of that triangle here, S. 5 over S equals the height of the lamp pole, 20. Over D plus S. You see that? So that's my relationship. I'm going to cross multiply here, and I get 20S is equal to 5D plus 5S. Now I'll subtract the 5S over, and I get 15S is equal to 5D. And I'll divide both sides by 5, and I get 3S is equal to D. Are you good with that? Let's take the derivative and see what happens. You know what I love about calculus too? Like when I ask a question, like if your answer is take the derivative, like you're probably right 75% of the time, right? It's like, what should we do now? Take the derivative. That's a good, yeah, let's go. I mean, think of the number of times we say that in a given day. You know what I mean? It's a lot. Okay, what's the derivative of 3s? 3s prime is equal to d prime. So I have this formula, 3s prime is equal to d prime. But what I have not done yet is I haven't really talked about like what we're trying to find or what we're given or anything. What does d prime represent? The rate at which he's moving away, right? Okay. This is the last important piece, and we might get confused here, but everybody agree that d prime is the rate at which he's walking away from the lamp. So what is that? 4. So we have 3s prime is equal to 4. So we can find s prime pretty easy then, right? Just divide by 3. So you have s prime is equal to 4 over 3. Now, that's not quite the answer. We need to think just a little bit further here. Can somebody tell me what does s represent? What does s prime represent? The rate at which the shadow is growing from him, right? So like he's moving as well, right? So the shadow is growing at a certain rate and then he's moving as well. So it's kind of like this. Okay, anybody ever been in an airport? And like there's those like moving like sidewalks, right? So let's say that the sidewalk's moving at 3 feet per second, okay? And let's say I step on it and I'm strolling at a rate of 1 feet per second, right? Well, how fast am I moving altogether? Yeah, because the sidewalk's moving as well. Get my point? So the shadow is moving away from him, but he's also moving. So when it says how fast is the tip of the shadow moving, it's his rate. What's his rate? So it's 4 plus 4/3. Or 12/3 plus 4/3, which is 16/3. And what's our measurement? Unit feet per second. Good work. You guys are smart.
So it had nothing to do with the 30.
The 30 feet from the pole means absolutely nothing to us.
Yes.
All right, take out your homework problems, and I just want us to do
Oh my gosh.
14 and 16 and 18. 14, 16, 18. That's it.
For homework?
Yep.
Yeah, I'll do any of these other things.
No.